Howdy folks. So in my last video you would have seen this 2-port SATA controller. It failed in my file server, and I've been so incredibly busy and I don't have any flux left, so I haven't gotten a chance to rework this to see if that was the issue, but I highly doubt it. I'm pretty certain it's an internal chip failure, and honestly I could not care less. It doesn't cost very much. I don't care. Anyway, one of my viewers who saw that video reached out to me and ended up sending me a proper server grade host bus adapter, a proper SAS adapter. And I'm incredibly in debt to this person. Her name is Alexi. She has her own YouTube channel, Lexi's Tech. There's not many videos there, but she sounds like she knows what she's talking about, and I'm very interested to see where that channel goes because there needs to be more channels like that. So if you're interested, I'll definitely leave a link in the description, and you can go check her out. But anyway, this card, which has come all the way from Australia, this is an IBM ServRAID M1115, which is a slightly better card to the very popular M1015. And I'm not going to be utilizing this. Of course, this is a full RAID controller, and I'm not going to be utilizing the RAID functionality in this because, of course, I have ZFS. So I'm going to be actually reflashing the firmware on this because, of course, under this heatsink, there is basically an onboard processor. This thing has its own firmware. It's basically its own operating system. And I'm going to be reflashing this into a different mode, which I'll talk about, and that will allow me to basically get a direct pass-through from the operating system on the server to the disks directly, and then I won't have to deal with the RAID firmware, which can cause problems with ZFS. You want to get as transparent communication as you can with your disks if you're using ZFS or ButterFS or any of those types of file systems. So this is a really nice card, and this, of course, like I mentioned earlier, this is a SAS card. So SAS stands for Serial Attached SCSI, which is quite a bit different from SATA, which is Serial Advanced Technology Attachment, which is what you're probably more familiar with. Now, SAS is, or should I say, can be quite a bit faster than SATA. Of course, the current standard of SATA is SATA 3, which is 6 gigabits per second. The current version of SAS is 12 gigabits per second, with the next version, which I believe is due to be out in 2017, which will double that to 24 gigabits per second. So SAS is very fast. And the idea behind, the thing is, the reason why you've probably never heard of SAS is because it is truly a server enterprise type interface. Really, you'll only see it on the very expensive enterprise class hard drives, which are designed to be more reliable than consumer drives, that kind of thing. And of course, they carry a price tag that's several times more than consumer drives. And one of the things with all of these SAS controllers is the interface is designed in such a way that they are, I don't want to say backwards compatible because that's not really the right term, because of course they're completely different interfaces, but SAS controllers are compatible with SATA drives, but not the other way around. So I can plug both SAS and SATA drives into this controller, but I can only plug SATA drives into this controller. I cannot plug a SAS drive into this. So you can buy these and you don't have to use enterprise class disks. And that's of course what I've got. I just have regular consumer disks. Mine are Seagate ST4000 DM000s, which are 4 terabyte disks. And in my opinion, they are incredibly good disks. I know a lot of people don't like Seagate, but they are very reliable disks. In fact, they're more reliable than some of the Western Digitals in that series, and they're very, very cheap. And I like the 4 terabytes because they're a good size. They have a good sort of cost to size ratio. Of course, the bigger the drive, the more expensive it's going to be, and the smaller the drive, you're losing out because you're paying for the base drive, but not for the actual capacity. So anyway, I'm getting sidetracked already. So anyway, of course, these are special connectors for SAS. These are mini SAS SFF 8087s. And of course, you cannot plug a standard SATA disk into this. So you need to purchase what are known as breakout cables. And breakout cables look like this. Now, remember I said this was an 8-port controller. Of course, it's only got 2 ports here. And that's because one of these mini SAS connectors splits into 4 SATA or SAS connectors. And I have 2 of these cables. And the SFF8087 is just a 32-way edge connector. Very simple. Probably don't need the cover, but I'm going to leave it on there. The cables are relatively expensive, far more expensive than you're going to find any SATA cable for, which is kind of disappointing. And one of the things that I really hope is that these cables are long enough. These are 1/2 meter cables, and it will be interesting to see because these ports are on the basically they're on the far side of the motherboard when this thing is upside down. So I just hope that this is long enough. We're going to find out. But you can get 1 meter versions of this, but I happen to have 1/2 meter versions, so I may be running out and getting longer cables. So one mistake that I've seen made when people buy these cables is they buy the wrong type because there are actually 2 different types of this cable and they look identical. And one of them is called a forward breakout and the other one is called a reverse breakout. And the reason why there are 2 different kinds of cables is basically how these things fit into your standard rack mount server. So if you have, let's say for example, you have a server, and in a server, chances are it's going to have some number of hot swappable drive bays on the front. Basically a cage with a drive that slides in, and you can basically remove it without having to take the machine apart. And the drive, of course, slots into a circuit board basically behind all the disks, and they have strategically placed ports such that the drives just slide and they make connection. There's no cables at all. And that board is called a backplane, and they're very common. And in most servers, the backplane will actually have one of these mini SAS connectors on it, and then what you'll do is you'll basically get a straight through cable. It'll have mini SAS on one end and then mini SAS on the other end, and you'll basically connect the backplane directly to this. And the backplane is what will do the single to 4-port expansion. It'll have all the required circuitry for that on the backplane. However, if you're in my situation where you've got just regular bare drives and a mini SAS on the controller, you need what's called a forward breakout cable, which goes from basically the SFF to SATA, SATA being on the disk end. The other type of cable, the reverse breakout, does the opposite. So it would actually connect the mini SAS to the backplane, and it would then connect the SATA connectors to a motherboard or a SATA controller like this. And it's a much stranger cable. They do make them. They are readily available. And they're actually usually cheaper than the forward breakouts because, of course, they're less common. So so if you're looking for a cheap cable, make sure you buy the forward breakout, not the reverse breakout. So before I start testing and flashing this card, I just want to give you a little bit of a overview of the card. Of course, we've just got mini SAS connectors there. Under here, which I could take this off if I really wanted to, but I'd rather not. You can see that there is a BGA chip under there. And of course, that's going to be our controller. It's going to have an embedded processor. I'm not entirely sure what architecture these things actually run. I am not sure. I'd have to look that up. We've probably. I really don't know the architecture of this board. I just received it in the mail no more than a few minutes ago. We actually have a bare die here, which I think is quite interesting. It's not encapsulated in. It's just a flip chip. It's not encapsulated in epoxy, as far as I can tell. And it would be very interesting to know if whatever that is susceptible to the photoelectric effect. This was an issue that plagued the Raspberry Pis for quite some time. They had a power management chip on them that was this style. It was not encased in epoxy, and if you used like a Xeon photo flash to take a picture of the board, the light would actually get underneath the chip, because of course you're looking at the back of the silicon die. It would actually get in between the balls and the board, and it would actually, it will actually expose the etched side of the die, and due to the photoelectric effect, it would actually cause the chip to malfunction. Of course, the Raspberry Pi would crash, and they've fixed that in later revisions. But I wonder what would happen if you took a photo with a actual proper photo flash on this board. I'm not going to try it, but it would be interesting to see what happened. Because of course, this is not designed to ever have that happen to it. I mean, it's designed to be in a dark server room in some closet somewhere. So obviously they probably don't care about that. It's got one LED on it, what looks like a bunch of unpopulated LEDs. On the back, we've got an Altera part, which looks to be a CPLD, but it could be an FPGA. I'm too lazy to look up the part number. 150 megahertz oscillator. We have what is probably some form of flash memory. It's got a barcode on it, so it probably indicates something to do with firmware, and just a bunch of other random stuff. So, well-made part. That is the actual official. This, of course, is an LSI controller, if you didn't notice. So this, even though it's an IBM part number, this is not an IBM design. There are other cards that look identical to this sold under other part numbers. It's basically an LSI reference design that's manufactured under license by IBM, and that's the actual LSI part number. And that's important because that's what I'm going to be doing. I'm going to be flashing. This, of course, will have IBM firmware on it, and I'm going to be flashing it with a different version of the firmware entirely, and it's going to be an LSI official firmware. So you might wonder why it is that I actually need this, and why I have this. Why wouldn't I just simply get another one of these? Why don't I just continue to use a bunch of these? And it's a valid point, and I mean, these are cheaper, so of course, I mean, if cost is ultimately something that, you really cannot afford this, then, these are okay. But there are a lot of problems with these, primarily with performance and reliability. Those are really the two main ones. Of course, the performance of this is going to suffer due to the fact that it's connected via PCI Express X1 version 2.0. And as a result, this is only 5 gigatransfers per second, which, if you actually look at both of these are SATA 3. They're 6 gigabits per second each. So the throughput, of course, is going to be limited by this right here. Whereas, of course, on a proper card, this is PCI Express X8. Again, version 2.0. It actually says PCIe 2 right on that card. That's nice. So, of course, with this, you will have the bandwidth required for the drive. Now, I've always argued that if you're using mechanical disks, then the bandwidth doesn't really matter that much, because the mechanical disks, of course, they're going to be limited by the fact that they are intrinsically a piece of spinning rust. They are slow because they're mechanical, and as a result, I have yet to see a physical drive that can actually saturate SATA 3. So that's sort of the claim that I've made, and I think it is still valid. However, of course, if you're using SSDs, this is not going to be a fun time for you. But also, drives are coming with bigger and bigger on-disk caches, right? The drives that I use, they're 4 terabytes. They have 64 megs of cache. And of course, the cache will be capable of saturating these links. So I do expect there to be a performance difference with this card versus this card. Both just due to that alone. And the other thing is, all of my drives will now be on SATA 3. Because right now, the way that I get all of the ports, I've got 2 of these, which provide 4 ports, and then the motherboard provides the other 6 ports, which gives me 10 ports, which is, of course, 8 for the disks and then 2 for the SSDs. And the SSDs take the SATA 6 ports that are on the motherboard, and the rest are half SATA 3, half SATA 2. So now all of my disks will be on this, and therefore they will all be SATA 3, which will be nice to see. The other thing, of course, is reliability. And this, of course, is designed, this is server grade equipment. This is designed to last. This is designed to be mass produced as cheaply as possible in a consumer product. And it's probably not going to be terribly reliable just from that alone, but when you put this into a server and you give it a workload that it's not designed for necessarily, that potentially could increase the rate of failure. So something like this, you're much less likely to have a problem. And like I've mentioned before, even if you use something like ZFS, ZFS is really only so good as long as the hardware is stable. And you can generally get away with potentially even, bad memory, non-ECC memory. And generally speaking, you will be okay with ZFS. But if you have a bad SATA controller, the SATA controller decides to write different things to the disk than what you instruct it to, then ZFS can't help you. Because SATA controllers, I have seen them completely murder massive ZFS data sets. And it's really not cool. Same thing with cables. You don't want the cable to go bad. I had one of the previous places that I worked, we had a large file server. It was huge. It was one of those double-sided Supermicro cases with 36 disks in it, 4U. And it had a whole bunch of Seagate cheetahs in it. And anyway, we were doing some maintenance on the rack, and we had to move the server, of course. The server couldn't go down. We had to move it around, and we rebooted for updates later that day, and the machine never came back up because what we think happened was the cheap cables, they had bad latches, and they wiggled loose a little bit, and they had messed up the ZFS arrays, and they could not be brought back up, and we eventually had to completely pave the machine and restore from backups, which was not fun. So I've got the card installed on my little mini ITX test board here. This is for another project, but it has yet to be installed, so I can use it for this. So I've got the card here, and I've had to make a FreeDOS bootable USB flash drive. I'm not going to give the exact instructions as to how to do the reflashing of this card, because you don't want to mess this up. So I'll put a link in the description which has got some instructions, and I'll just do a really high level overview. If you want exact commands and stuff, I encourage you to read them out of a document, not out of this video. So anyway, I've got the card in, booted into FreeDOS. You've got to have high mem enabled, and the reason why I'm using FreeDOS is because the first command you need to run erases the IBM specific information from the card so that LSI's flashing utility will be able to find it. And this utility only exists for DOS, so you can't boot it over EFI or anything. So you boot into FreeDOS, and you can run it. You basically basically you empty the SBR, and then you clean the flash, and it'll take a little bit, and it'll work fine, and you should get success at the end of this. If you don't boot FreeDOS into high mem mode, which is not default, this program will crash when it tries to start. So you need to make sure that I think it's boot mode 3 if I'm not mistaken. I don't even remember. But anyway, so you do this, you reboot, and then I have to be able to do some EFI stuff from this. I've actually already copied all the EFI stuff onto this, so I should just have to reboot and load into the EFI shell, which is very annoying on this board. The reason you'll notice I've switched from HDMI to VGA is because on HDMI the EFI shell doesn't scroll, so it gets to the bottom of the screen and it starts drawing commands off the bottom and it doesn't scroll up. So once you fill up the screen, you can't see what you're doing anymore. But on VGA it works. So MSI needs to get their shit together. So I've rebooted, and I've gone into an EFI shell. The way that these boards do it is you can select EFI shell from F11, and then you can basically CD into this drive. ASUS boards have a way to get to it from the BIOS config, which is a lot easier than this, but anyway, it doesn't matter. Basically you just do a flash, and then you add basically the serial number of the card, which is located on this sticker right here, and everything's gone okay. So I'm going to power cycle the board and boot into a real operating system. So I'm going to stick a hard drive on this, and hopefully the card comes up and is working. I mean, the LED's flashing, so it's obviously got a firmware now. So cross our fingers that it's detected and works okay. So here we are. I've got my test drive connected to the motherboard SATA controller, and this has to be this way because I did not install the BIOS onto this, so it's not bootable. You can't boot from it, but I don't want the BIOS on there. It just makes the boot really slow and it's really bulky. It doesn't need to be there. So I've just got a 1 terabyte disk here, which is connected, of course, to SAS port 0 here, and it all looks good. So if we do an LSPCI, you can see we have the SAS controller right here, L-side logic, SAS 2008, and the disks are showing up, and I can, this 1 terabyte disk here, this one is connected over SAS and over the SAS controller, and everything in the kernel log looks good. So yeah, this is pretty great. So I am going to take down the file server and start swapping some stuff around. So here's Tesla before the upgrade, and this is what we got to deal with. So I got to pull all this out, and this is what the other side looks like, by the way. So it's pretty standard. It was about as well cable managed as I could get it. Anyway, I'm going to do this all off camera because I'm kind of against the clock here, severing all those high-speed network connections. My server's not terribly happy about that, so I'm going to hopefully get this done as quickly as possible, and I'll show you what it looks like when it's done. So I've taken the two existing HBAs out, put the new one in, and I've wired it up, and to my luck, the cables were just barely long enough. It looks worse than it really is. There isn't really any strain on those cables, on the connectors on the ends. Of course, that's what you really want to be concerned about, but it's fine. I just wasn't able to use the grommets. I had to go directly behind the drive cage to get the length. So it's kind of my fault. I didn't measure it, including the bend that the grommets would take up, and I probably should have got 1 meter cables, but for now, this is good enough. So I'm just going to double check all the connections on all the drives, make sure nothing wiggled loose, put the panels back on, and fire up the server. And if everything's good, then I'll be leaving this for a while. I probably should clean this thing and dust it out and stuff, but that'll be a later thing as well. So I booted the server up, and it's up on SSH. So I'm just going through the logs here, and the kernel log all looks good. You can see that the card is bringing up all of the links, and it's detecting all of the disks. So that all looks good. And I've checked the ZFS status, and it's all good. All the disks are detected. They're all online, so this proves that all 8 ports of that controller are up and working. The kernel has no issues with it. I've lost all of my serial number mappings because I've changed ports. ZFS on Linux, as soon as it sees a disk move, it just aborts and goes back to the standard mapping like this, which I generally don't like because it's harder to. You then have to basically look, oh, if this disk has failed, I have to reverse from SDC to whatever actual serial number it is, and then I can find it in the chassis. So I usually like to map it like this, where I use the serial number, but I think I can fix that at some point in the later date. It's not that important. All that's important is that it's working and I can get my network back up and running. So yeah, I think that's really all there is to say about this. I'm not even going to bother to benchmark it because I've tried that in the past, running things like Bonnie++, and they just the ZFS ARC is just so good that it sort of says it's too fast. I can't benchmark it. I can't come up with a real number. So I'm not even going to bother to do that. I mean, it's going to be probably very similar performance. If there's anything really, really different about it, maybe I'll make a separate short video about it. But the only thing I could really think about that may sort of indicate performance is the scrub speed. So it seems to be scrubbing at 9.5 hours. So basically tomorrow, which is Wednesday, it will do another scrub. And if that is significantly less than 9 hours, 31 minutes, then I could say that that is attributable to an improvement in the HBA, simply because the amount of data has not gone down. So anyway, maybe I'll put it in the description if anything's changed. But anyway, I've definitely gone on way too long. This video was not supposed to be this long. So anyway, hopefully this was interesting and maybe you learned something. And as always, thanks for watching.